Hi guys, this is just the lesson for Friday, October 30th. Today you have the Unit 1, Lesson 2, Interactive Notebook, slides 5 through 8 due. And so when you log into Schoology, we'll do 6th period this time. When you log into Schoology, in between the general resources folder and the week 9 folder, you have your U1 L2 interactive notebook. When you click on that, it opens your own document. And so due today is the slides 5, 6, 7, and 8. And due on Tuesday is slide 12. So today in class, we are going to do slides 9, 10, 11, and 12. So that will be today. You need to make sure that you have your Unit 1, Lesson 2 digital IMB open. Pear Deck hasn't been working for me, so we won't use that. The attendance question, best Halloween costume idea or something you're looking forward to. Just a recap of our homework that's due today. You are supposed to use the reading that's on INB slide 4 and the 2 videos on slide 5 to help you do the Frayer models on slides 6, 7, and 8. So I have my examples here for speed. Remember, speed is the rate at which an object changes its position. We use the formula of distance divided by time to calculate speed. I decided to do a speeding car as my example and running. And then a non-example would be a building standing still. For velocity, this is another unit of measurement. We use it to measure an object's speed and direction. So the example I have there is 20 kilometers an hour to the west. We have a formula here. That triangle means delta or change. That's called a delta and it means change. So change in position divided by change in time. My example is an airplane making a banked turn. Some other examples could be a car stopping or slowing down. And when I drive to school, I go about 50 miles per hour on average to the south, because I live north of the school. A non-related example would be an object that's not moving. So velocity is like speed, except for it measures also the direction. Acceleration, remember acceleration, these are new definitions for acceleration. It's any change in speed or direction. So it's not just speeding up, it's also slowing down and turning. And so the picture I have there is a picture of runners running around a corner. They're accelerating because they're changing direction. A non-example would be a car going at constant speed. I don't think I have my sound shared, so I'm gonna go ahead and make sure I add my computer sound. Turn down my volume so it's not super loud. So we're gonna use this video in the example to help us calculate speed today. So remember, to calculate speed, we're dividing total distance an object travels by the total time it took to travel that distance.
We have already seen in our previous video what average speed of an object in motion is. Let's understand it one more time, as this is an important concept. First of all, how will you define the speed of an object moving along some path? The speed of an object is the distance traveled by an object over the time it takes to complete that distance. Say the distance d is 20 kilometers and the time it takes to cover this distance is 4 hours. What will be the speed of the car then? Yes, the speed will be 20 over 4, that's 5 kilometers per hour. Look at the value carefully. What does it tell us? Does it mean that our object traveled 5 kilometers in every hour? Or in other words, does the value of speed say that the object traveled at a constant speed? Well, we know for a fact that the car does not magically start directly at a speed of 5 kilometers per hour. Its speed gradually increases. So if the car was starting from this point, then its speed cannot be constant. What if this was not the starting point of the car? Well, we still cannot say whether the speed was constant or not. Because maybe the car was slow in the first half of the journey and then sped up in the second half. The given data does not imply in any way that the car will cover 5 kilometers in every hour. So if this is not a constant speed, then what is the speed called? This speed is called average speed. Average speed is defined as the total distance covered by an object over the total time taken. So in our example, we are given a total distance that the car travels and the total time taken by it to cover that distance. And hence we calculated the average speed of the car for the entire journey. I'm sure that you're clear with the idea of average speed now. So what's next? Look at the unit of speed used in the example. The unit of speed in this example is kilometers per hour or kmph, and it's one of the most common units of speed. Yes, this unit is also used in speedometers. Suppose a car is traveling from point A to point B and the speedometer shows these values at these 3 instants. Notice at time t2, the speedometer reads 30 kilometers per hour. What does that mean? Is this an average speed? No, it's not an average speed. The speedometer shows us the instantaneous speed. It is the speed at that instant of time. Here, the speedometer reads 30 kilometers per hour. It means at that moment of time, the car is traveling at this speed. It does not say that the car has been traveling at this speed or will travel at this speed. The value is only at that instant. And that is why we see that the pointer is never really constant in the speedometer. It keeps fluctuating. You are going to learn more about instantaneous speed in our higher grades. In the next video, we're going to see some of the units of time. See you there.
All right, so remember, we are using the formula of distance divided by time to calculate speed. We have this example of Steve throws a football 50 meters and it takes 3 seconds. What's the average speed of the football? We have the example here with the formula distance divided by time. Our distance is 50 meters. Our time is 3 seconds. So 50 divided by 3 is 16.6 meters per second. And so that's going to be the speed of the football, 16.6 meters per second. So we're gonna practice calculating average speed and velocity on INB page 10. So you can do this along with me on page 10 of your interactive notebook. Our first problem, we're calculating the average speed it takes to get from Kenmore Middle School to the Alderwood Mall. I have a screenshot here of our Google Maps directions from Kenmore to Alderwood Mall. You'll notice down here at the bottom, we have our distance, our time, and then we can see the direction on the map there. In order to calculate average speed, we need to know what is the equation for calculating average speed. Hopefully you said distance divided by time. That is the equation for calculating average speed. So for this investigation, what is our distance? Well, we can see our distance down here at the bottom of the map, 4.9 miles. We're gonna round to 5 miles. Next unit we need is the time it takes to travel that distance, and we have that right down there at the bottom as well. It says 15 minutes, but we want to find miles per hour, not miles per minute, so we're going to convert that into hours. So 15 minutes is 1/4 of an hour, or 0.25 hours. We're going to solve for the average speed, distance divided by time. 5 divided by 0.25 is 20. So that means 20 miles per hour is our average speed for the, if it takes 15 minutes to get to the Eldred Mall, you're going about 20 miles an hour. The velocity is speed and direction. So we know our speed is 20 miles an hour. Now we got to figure out the direction. We start here down south and we head north to Alderwood Mall, then we know our direction is north. So our velocity is going to be 20 miles an hour north, 20 miles an hour north. So on slide 10, you should have these filled in. Distance is 5 miles. The time is 0.25 hours. The average speed is 20 miles an hour. And our velocity is 20 miles an hour to the north. On this next problem, we're going to be calculating the average speed if I am driving to visit my brother in Conifer, Colorado. We're going to round our time to 20 hours. And do notice there was a typo. On yours, it says velocity, in parentheses, it says direction plus direction. This should be speed plus direction. So go ahead and make that adjustment there. Speed plus direction. All right, when I drive to my brother's house, which I do often, what distance am I driving? What distance am I driving? So take a look down at the bottom again. Hopefully you said 1,342 miles. I got that from down here, 1,342 miles. How long does it take me to get to Colorado, Conifer, Colorado to be exact? $20 hours. It takes me 20 hours to go from Kenmore to Colorado. All right, to solve for average speed, we need to do that distance, 1,342, 1,342, and we divide it by 20, divided by 20. So we have 1,342 divided by 20, and we get 67.1. 67.1, and we're doing miles per hour. So 67.1 miles per hour for this one. And then we're looking at the direction. Washington's in the northwest corner, and you can see that to get to Colorado, I need to go southeast. So my velocity is 67 miles per hour, my speed, plus the direction, southwest, or southeast, excuse me, 67 miles per hour, southeast. All right, practice determining speed. We are now on IMB 11. These should look familiar because these are straight out of our pre-assessment, the Unit 1, Lesson 1 slides. I took the exact same problems. I put them in here so that we could practice with something that looks familiar. Most of you guys were really great at answering this question, which car is traveling faster? You could look at these graphs, look at the table, and you could tell, I can tell which car is going faster. I'm gonna teach you how to tell why it's going faster. So the data table on the right was used to create the two graphs on the right. I want you to use the table and the graphs to answer the following questions. What is the speed of car number 1 between 0 and 0.8 of a meter, 0.8 meters? So we're looking at car 1 between 0 and 0.8. And so I know my distance is this 0.8. The car has gone from 0 to 0.8, so that's 0.8 of a meter. And how long did it take it to travel that distance? Well, it took it 5 seconds. So I'm going to go back to my calculator and I'm going to clear this and I'm going to go 0.8 is my distance. So 0.8 of a meter divided by 5 seconds. And I get this fraction, which would make sense because I'm dividing a fraction by a whole number. So I have 1/1600ths of a meter per second. So my distance is 0.8 of a meter. My time is 5 seconds. So I end up with 1/1600ths of a meter per second. What that means is the car has traveled 1/1600ths of a meter, just a very small section of a meter in 1 second, which would lead me to believe that this is not a real car. This is probably a toy car that we're looking at here. All right, for question 2, I want you to take a look at car 2 and tell me what is the speed of the car between 0 and 0.9 of a meter. You need the distance. So how far has this car gone? You need to know the time. How long did it take to get there? Then you're going to divide the distance by the time. All right, hopefully you came up with the distance being 0.9 of a meter from 0 to 0.9, that's 0.9. And it took 15 seconds. So you divide 0.9 divided by 15 and you got 0.06 meters per second. So this car is clearly traveling slower than this one. We can tell by this number. Most of you, like I said, you could see on the graph, car 1 is definitely moving faster than car 2. We can say that because this graph is steeper. When you have a steeper line, it means it's going faster. You can also see that in 20 seconds, car 1 went 2.2 meters and car 2 only went 1 meter in the same amount of time. So for all of those reasons, we can say that car 1 was going faster. It's going faster because the line is steeper on the graph. We know that means the car is going faster. We can say it's going faster because in the same amount of time, it went more than twice as far. And so car 1 is our faster car. Your homework due on Tuesday. INB slide 12, you are coming up with your own example of calculating speed. So in your example, I want you to have a description of the scenario, kind of like me saying you had to calculate from Kenmore to the mall. Maybe you're going to Disneyland. Maybe you're going to a friend's house. Maybe you're going to your parents' house. Maybe, I don't know, something, going somewhere. So I need a description of the scenario, not too long. A picture, it could be a Google Maps, a screenshot of the Google Maps, or it could just be a picture of the place you're going. I need to know the distance you're traveling, how long it takes to get there, and I want you to calculate the speed and velocity on that. So That is your to-do list for this weekend. Should not take you more than 30 minutes to complete this task. All right, you know, I'm always available by email if you have questions. And have a wonderful weekend.